Welcome to the project demonstration of automatic power factor correction along with Thingspeak monitoring. So the main application of this project is we are going to do the power factor correction whenever inductive load was on. Means generally the resistive load we are representing with this 100 watts bulb, and 40 watts load is tubular choke, and the capacitive load we are using 2200 microfarad of capacitor for 450 volts. So R L C. So whenever the R resistance load connected, then the phase difference between the current waveform and voltage waveform is nearby zero due to this resistive load only. Then when the phase difference between the current waveform and voltage waveform is nearby zero, then the cos theta value, the theta nothing but phase difference between these two waveforms, voltage and current. So the cos theta value nothing but cos 0 is nearby 1. That is called unity power factor. So in order to maintain the unity power factor, we need to compensate the current waveform whenever the inductive load was attached. Means when we place the inductive load in series with the bulb, nothing but resistive load, due to this inductive load inductance, then the current waveform will lags. So due to this lagging, the voltage waveform and current waveform phase difference will be increased. So whenever the degree of phase difference is increases, then the cos 0 nothing but cos theta value will be decreases from 1 to 0.9, 0.8, 0.7 based on the difference between these two waveforms. Means phase difference between these two waveforms. So then, as we know that inductive load will lag the current waveform, capacitive load will lead the waveform. Then whenever this inductive load was detected, then the current waveform lags and the power factor will be comes from 1 to 0.9 or 0.8. Then the Arduino UNO will continuously measure the phase difference between these two waveforms. When it lags, then the system will on this relay to attach this capacitor in parallel to the R plus L. So R and L on series, and to these two loads we place this capacitor in parallel, and that will be connected with the help of this electromagnetic relay. So here you can see this parallelly we have connected that with the help of this relay. So in that manner, then the current waveform will be lead, then the phase difference between these two waveforms will be comes down from somewhere to the near to the zero. Then again we are going to maintain the power factor for unity. So whenever it is above 0.9, then we are considering it as a normal power factor, which is nearby unity power factor. Whenever that is less than 0.9, then the system will check with the by on this relay to connect this capacitor in parallel to the R plus L loads. So these are the main feature of this project, and continuously we are going to upload the same power factor value to the Thingspeak cloud platform, and this can be accessed from anywhere in the world. Like just click on the dot, we came to know the power factor value and along with the date and time. So to on and off the inductor in series to the bulb, we are making use of three switch. We are going to do that manually, but power factor correction will be done by automatically with the help of this relay, which is electromagnetic relay, will be controlled through this Arduino UNO board. And this is the features. And coming to the modules, so main power source we are providing 230 volts AC inputs that is parallelly connected through this 230 volts load, that's R L C, through this parallelly connected along with the current waveform, and in this one voltage waveform will be connected. So this is the board of regulated power supply board, which will take to 230 volts AC inputs and provide us the 5 volts DC outputs. That is the main operating voltage of our main components. 5 volts DC is the input voltage to the microcontroller, that is nothing but Arduino Nano, and LCD display, all the components along with the ESP8266 Wi-Fi module. And this current waveform and voltage waveforms continuously read by this Arduino UNO board from these pins and displaying the power factor value on the LCD, which is connected pin number 2 to pin number 7, and ESP8266 Wi-Fi module, which was connected at the pin number 8 and 9. 12th pin was connected to this electromagnetic relay. So these are the main input output connections of our project. And coming to this zero crossing board, so it has the resistors to make the voltage to the 10 volts, as we are getting around 230 volts, and that will be regulated to using this potential divider, and this is converting pulsating DC to get the pulses input to the Arduino UNO board. So these are the components explanation. Let us see demonstration. Before demonstration, first of all we need to on the hotspots. For that, go to hotspot settings and configure the hotspot name to project 7334. So without any space, without any capital letter. So this is the configuration we need to do. That project 7334 and password should be 123456789 and AP band should be 2.4 gigahertz. So after enabling the hotspots and data, log into the Thingspeak cloud platform. Right, stay on the screen. So before if you want to get the live data, or if you want to erase the old data, or if you want to download the data, then just explain you that. For download the data, go to data import export and download the data, and it will be downloaded and stored in Excel sheet, and we can access that Excel sheet directly opening that, and we can get the date and time along with the number of samples till now collected in this one. So after you took the backup, you can erase the data. So the thing is date and time and number of samples till now we have collected 12, and this is the power factor values at which time the power factor was calculated. And after we took the backup, now go to channel settings, and in that only clear channel. And so after successfully clear the channel, I will get the pop-up, and now go to private view to get the live data. Channel settings to clear the channel, data import exports to download the data. Now the old data got erased. Now stay on the screen. Okay, so now before on this we should on the hotspot and data. Now on the power supply. Right, initially only R load will be connected, that's why it's getting with the high brightness, as there is no series load, nothing but there is no inductive load was connected to that. And we can see one device connected in your mobile phone, and the power factor value is as of now 0.92, 0.96. It will varies between the 0.9 to 1. And right, so we got the one sample. So the data will be uploaded for every 15 seconds of duration. Right. Okay. So now let us add the inductive load. When we add the inductive load in series to that, then the voltage will be divided V1 plus V2, so that the brightness of the bulb will be controlled. So it's lagging. Now it will start calculate the power factor. So done, and now it will on this relay. We can see that the relay got switched on. So the power factor compensated again after we switched on the relay to this. And for every 15 seconds duration, keep on uploading the data to the Thingspeak cloud platform. Right. Okay. And now when we off this, then only R plus L was detached. Then only C was attached already by the relay in the automatic power factor correction method. Then only R plus C will be there. As we discussed, C will lead the current waveform, so that the power factor value also will be leads. So you can check that. Right, it's leading power factor now. So whenever we talked about the power factor, we should mention the power factor value along with leading or lagging. That is very important. So if you can recheck the system. Then we get to know the power factor value directly. So in this manner, power factor lagging will be done, R plus L, and when R plus L was there, then the Arduino will take a decision to on this relay. Then the relay will be attached this capacitor in parallel to this one, so that R plus L plus C. Then the power factor nothing but corrected. And when we disconnected this, then a microcontroller will check the power factor. If it is leads, then the system will off this relay to disconnect their capacitor in parallel to this R load, so that again it will be compensated. Leading, lagging will be done automatically with the help of our Arduino UNO board. Right, so we can do the power factor values continuously. Thank you.